Homework 3 then, determine whether each of the following ordered pairs is an element of the solution set of the inequality given. So we're going to substitute each coordinate into this inequality. So 8 times 2 minus 3 times minus 2 is bigger than 6. 16 plus 6 is bigger than 6. Yeah, that's true, isn't it? Next one then. 8 times minus 1, so minus 8, minus 3y, so 0, is bigger than 6. That's not true, is it? So that's false. The next one, 8 times 1, so 8 minus 3 times y, so minus 6, is bigger than 6. That's not true, is it? This is going to be 8 times, so 0 minus 0 is bigger than 6. That's not true. And then the last one, 8 times 2, so 16, minus 3 times 4, minus 12, is bigger than 6. Again, that's not true either. Okay, so we're going to graph the solution set of these inequalities. So we know the first thing we've got to do is draw the line y equals 4x minus 12. I'm going to use 2 units per square. Now there's loads of ways you can draw this line. You could make a table and plot some values for x and y. So when x is 0, y is minus 12. When x is 1, y minus 8. When x is 2, y is minus 4. Plot those 3 points, 0 minus 12, 1 minus 8, 2 minus 4, and then draw a straight line. Now you're going to have to excuse me because it's a bit difficult for me on this. Let's plot a few more points. Should have 1 there, 1 there, 1 there, 1 there. And then just rub this out. Oh. Or something like that. You're going to have to excuse the inaccuracy of that line. And then it says y is less than 4x minus 12. So we've just got to decide which side of the line satisfies this inequality. So the simplest thing to do is to choose a nice easy point. So let's choose the origin. 0 is less than 4 times 0, which is 0 minus 12. Is 0 less than minus 12? It's not. So this side is not the side we want. The other side, it turns out, is the side we want. And if you want to be sure, we could choose a point and substitute it in. So we could substitute, let's choose this point here, which is 7, 0. So 0 is less than 4 times 7, 28 minus 12. And yes, it is. The only other thing we've got to do then is look at the inequality sign. It says strictly less than, and we have to express that using a line. So we need a dashed line in this case. And then always good to make sure we label that line clearly. We know that's the line y equals 4x minus 12. Exactly the same situation then. In B, we're going to need to draw this line 3x minus 7y is greater than or equal to 21. Sorry, is equal to 21. So again, we plot ourselves a nice table. X and y. When x is 0, and x is 0, we then have minus 7y is equal to 21, and so y is equal to negative 3. Now if we continue with this, so if let's choose x is 1, then we're going to have 3 minus 7y is equal to 21, minus 7y is equal to 18, y is equal to 18 over negative 7. Now that's a really difficult point to plot in terms of getting the accuracy right. So the best thing to do here might be to actually rewrite this equation in slope-intercept form. So make y the subject. And so we can see if we add 7y to both sides and subtract 21 from both sides, end up with this. And then we divide everything by 7. So let's just put y here. Y is going to be equal to 3 over 7x minus 3. And so what we can do now is we can draw this graph using our slope and intercept. So I'm just going to write that over here and just rub this out. And so what I know about this graph is that the y-intercept is -3 and the slope is 3 over 7, which means that if our numerator is the y value, or the change in y, the denominator is the change in x, that means that every time we go across 7 squares in x, 1, 2, 3, 4, 5, 6, 7, we go up 3 squares in y. So if we went down 3 squares, we'd have to go back 7. Is that 7? 2, yeah, that's all 7, isn't it? And then with those 3 points, we can make our line. And again, it's not going to be the most accurate line. Something like that. And then we're going to choose a nice easy point to see which side of this line we're going to be shading in to show which side satisfies this inequality. Again, I'm going to choose 0, 0. So 3 times 0, 0 minus 7 times 0 is greater than or equal to 21. So 0, 0 is on this side of the line. It doesn't satisfy the inequality. So that means that the side that does satisfy the inequality must be the other one. And so we're going to shade in this side here. Do we need to dash the line? We don't, because we've got greater than or equal to. Okay, C then, we're going to have to draw the line x equals -2. For some reason I've drawn 2 there. And here's the vertical line x equals -2. And we need to dash that line because we've got strictly greater than. And then we want x is greater than -2. And there we go, all of this side would be greater than. Y is less than or equal to 5, so we need to draw the line y equals 5. 1, 2, 3, 4, 5. There we go. And we want y is less than or equal, so we want everything underneath that, and we leave the line whole. What have we got here then? Well, our line is y equals -2x plus 2. And we've got to decide, is this shaded region, is this where y is bigger than 2x minus 2x plus 2 or less than? What we can do in this case is choose any points from the shaded region. So let's choose 2, 0. And let's substitute it in. 0 minus 2 times 2 minus 4 plus 2. So we've got 0 minus 2. So you can see that 0 has to be bigger than -2. So we know then that y, this is the region where y is bigger than -2x plus 2. And we can see that the line is not dashed, so it's where y is bigger than or equal to -2x plus 2. And that's the end.